the answer? So, pardon me? Ca with a 2 plus. Now, why is it a 2 plus charge? Because it's in group 2A. This is that whole thing that we did with the ions, okay? That's what, with the representative elements. You are going to be able, or you are able to tell what the charge is on a representative element ion based on their position on the periodic table. We know that all the group 1A elements form a 1 plus charge. All the group 2A elements form a 2 plus. 3A is 3 plus. 5A 3 minus, 6A 2 minus, and 7A 1 minus. It all has to do with the number of electrons that are either being added to or lost from the valence shell. You guys remember all that stuff, right? Possibly got introduced that way back when we took physical science. We went over it again fairly thoroughly, I thought, the other day, right? Great. Representative elements, their charge is determined by their position on the periodic table. They only form one charge. There are two exceptions to that. I don't think we got to them in this class. Okay. The two exceptions for the representative elements are lead and tin. You'll notice that lead and tin are representative elements. What type of elements are they? They're metals. Okay, so we know they're going to form what sign charge? What's the sign going to be of the charge? It's going to be positive. They're metals, okay? However, even though they're in a representative group, they actually do form two different charged ions. One of them is a 2 plus, the other one is a 4 plus, and that is true also for tin. There's a 2 plus and a 4 plus. Okay? Now, here's the question. If this is the case, how am I going to tell the difference with the name? We're going to use Roman numerals to tell the difference between the name. That's why I played that little stupid song the other day. Okay? You guys have dealt with Roman numerals before with some, did I talk about the transition metals yet? A little bit? Okay. So, what do you think tin's going to be, this one? Yeah, we would say tin 2, and the other one's tin 4. Okay? Those are the only two exceptions to the representative elements as far as they're the only two that form more than one ion that you guys are going to need to know. Yes, Gracie?
But aren't they all like the fourth column and the second column? Why are they not?
I understand that, but because the deeper you go on the periodic table, the further down the periodic table you go, the more exceptions there are. We're going to find out when we get to chapter 4 in the next chapter, the whole electron configuration thing, which you guys don't know what that means yet. The further you go down the periodic table, the more exceptions there are. Yes?
So are carbon and silicon?
We have not talked about carbon and silicon. We're not going to talk about carbon and silicon. I'm not going to ask you about carbon and
So
silicon.
the only one that you're worried about in this
Tin and lead.
Okay.
Yep. All right. What if I did something like this? What would you guys write? Potassium. Pretty straightforward, right? Okay, I agree. Then, what about the transition metals? Did we get a chance to discuss these yet in class? I may not have, that's why I wanted to make sure we covered this. Okay. I think 1 or 2 of my periods we actually got to have a small discussion about that. Turns out that most of the transition elements can form more than one ion. Now, what's the charge of all those going to be? What's the sign of the charge? Transition metals. They're all going to be positive. They're all going to be positive, okay? However, since most of them form more than one charge, we have to do something very similarly to what we had done with tin and lead. We're going to have, their names are going to have a Roman numeral, okay? So for example, if I gave you this, first of all, you'd have to recognize that iron is indeed a transition metal, therefore, it's going to be able to form more than one charge, so we're going to have to indicate which one that is. Would anyone like to take a stab as to what we would write? Iron 2. Now, this is a kind of a convention type thing. There is no space between the parentheses and the last letter of the name. I tried to emphasize that when I wrote down the tin and the lead and everything. I don't know if anybody noticed that or not. There is no space. The parentheses comes right after the last letter. Okay, so what if I gave you, say, this? Yeah. Over here you would write chromium, what? 6. And what if I gave you that? What would you write? Why aluminum? It's a representative element. I know, that's why I did that on purpose, because you guys are going to be, I know how you guys go sometimes when you're answering these questions, you go in a hurry, because you want to remember everything, okay? And you just kind of fell into the trap a little bit, okay? So the representative elements names do not get Roman numerals. The transition metal names do get Roman numerals. Now, here's the deal. If there were exceptions for the representative elements, there's probably exceptions for the transition metals, right? And there are. There are of the elements that I had you learn, okay, which obviously was just barely over half of the elements. Of the elements that I had you learn, 3 of those fall in the transition metal category that do not form more than one ion. And so you're just going to have to flat out memorize what they are. They are, and I'm doing this in a particular order on purpose, silver only forms a 1+ charge. Only ever forms a 1+ charge. Zinc only ever forms a 2+ charge. And lastly, scandium only ever forms a 3+ charge. So 2 things that you need to keep track of there. You have to know their charges. And you're not going to be able to determine silver's charge based on its position on the periodic table because it's not a representative element. You're just going to have to flat out know that silver's a 1+. Same thing with zinc. Zinc's a 2+, and scandium's a 3+. The other thing you'll notice is those names don't have Roman numerals. Right? So, just like these are exceptions for the representative elements, in which we have 4 elements that do get Roman numerals because they can form more than one charge, whereas most transition metals do get Roman numerals, these 3 do not. Okay, there's that. And then one last thing about metals, positively charged ions, that has not appeared anywhere yet. Here is a transition metal ion that is a little interesting because it also forms two. Mercury forms two different ions. Okay, except one of them is diatomic. What does that mean? Obviously, two atoms. Okay, this charge is this, and this charge is that. So now we have another issue. We have two different mercury ions, or two mercury ions that have the same charge, but they're clearly different. Would you guys agree with that? So how are we going to distinguish between the one on the left and the one on the right? Well, once again, their names are going to use Roman numerals again. What Roman numeral are we going to use? Well, this one's pretty easy. If I'd given you this one first, you guys would have all automatically shouted out Mercury 2. So this one is no different than anything that you've considered so far with the transition metals. Okay? This one's a little strangely though. So let me give you a little hint. How many mercury atoms are here? Just one. What's 2 divided by 1? 2. How many atoms are here? 2. What's 2 divided by 2? And so that one's mercury 1.
And that's for everything?
No, that is only for mercury.
Okay.
Mercury is the only one that we are going to need to know that does this. So I'm going to let this sit here and absorb into your brain for a little bit. I'm going to guess some of you have some questions. Most of you have done a good job of asking questions as they came up. But does anyone have any questions before I move on to the nonmetals? I think you can see that the quiz is going to be very similar to the other one. There are a couple little things that we need to know though. Any metal questions? Okay. All right, well, I'm going to move on then. All right. We haven't really talked about any of the nonmetals yet. Now, as it turns out, as you know, as far as ions are concerned, there's really only a relatively small number of the elements I'm having you guys know that actually form ions. None of these form ions, correct? So we're not going to have to worry about these at all, okay? I've already kind of thrown out, I forget who asked over here, carbon and silicon. Remember, we haven't talked about those yet, right? We're not going to talk about that. There's a whole, the chemistry of carbon is a whole branch of chemistry. Anyone happen to know what that's called? You may not know. It's okay. You ever heard of organic chemistry? Any of you have any older siblings that might have taken some chemistry classes that, no? Okay. What's that? No? Okay. Anyway. So really, we're only dealing with a relatively small number of non-metal ions that we have to worry about. The thing here is, whoa, let's learn to spell. We're going to throw the suffix IDE onto the end of their names, the nonmetal ion names. As it turns out, I can think of 3 of these that you guys already know that this is true for. You just haven't thought about it. So what was that? I forget what I was talking about. Don't write this down. What was this? What was the name of this again? Carbon dioxide. What's that stuff that's in your toothpaste that helps prevent cavities? Fluoride. What's that stuff you sprinkle on your French fries, a little white crystal? Salt. Sodium chloride. See where I'm going with this? As you guys already know, oxygen, chlorine, and fluorine are all nonmetals. Their ions, names change to IVE. You're familiar with that, okay? So the rest of these aren't going to be that big of a deal. But I'll walk through them with you anyway. Let's start with group 5A. We're going to walk through these three elements right there. What charge do those elements form? The nitrogen, phosphorus, and arsenic ions. They're all 3 minus, okay? Some of these are very, you're going to be able to figure out pretty well. Does anyone want to take a stab for nitrogen's ion?
Nitrite.
That's exactly it. Nitride. Now, we are going to have to learn to enunciate very well, because has anyone started studying for the polyatomic ion quiz yet? Okay. Have you run into nitrate and nitrite? Okay, so we have to be very careful when we're speaking to each other, whether we're saying nitride, nitrite, or nitrate. You know what I'm saying? Because they're all 3 completely different things. All right, this one's a little tricky. Does anyone want to take a stab? Try to keep it simple. Phosphide is correct. Have you guys been exposed to this before? No. Okay, that's good then. You guys did well there. And anyone want to take a stab here? Was that Leah? Arsenide is correct. So you guys are kind of intuitively able to do this a little bit anyway. Okay, moving over to the next group, we have what charge does oxygen form its ion? 2 minus. We have sulfur, and we have the selenium, and I believe we go down to the tellurium ion also, don't we? Okay. We already know O. What's that name going to be? Oxide. Anyone want to take a stab for the sulfur ion? Sulfide. It is sulfide. Very good. Sulfide. How about selenium?
Selenite.
Very good. And finally, what about tellurium? It's a city in Colorado. Telluride. I've had somebody say Denver-ide before. I really have. Telluride. And lastly, some of these you already know. What charge does the fluorine ion form? Or minus. So we have fluorine. We have chlorine. We have the bromine ion. We have the iodine ion. And that's good enough. Okay? We already know this one. Fluoride. By the way, it's a good thing I told you that little trick about the fluorine, because I saw a number of people kind of start writing out the name of fluorine and then misspell it and go back and change it. So that was good to see. Chlorine, we already know. It becomes chloride. Anyone want to take a stab for the BR? Bromide. And what about the iodine? Are you okay? Are you sure? Iodide. Okay, there you go. That's it. What is that, 11? 11? What's that?
I said iodide looks weird.
It does. That's what it is. Any questions on these? That's pretty simple, isn't it? 3 of them you already knew. The rest of them you can you guys kind of intuitively were able to figure out. So here's where I'm going with this. Instead of having to say the chlorine ion, we can just say chloride. And since we know it ends in IDE, we know we're talking about the chloride ion, and so on and so forth. Okay? So if you hear sulfide, you're thinking S with a 2 negative charge. Good to go there? So it's a language. You guys, I mean, I know you're all probably taking a language right now anyway. Is that correct? Many of you, most of you, okay? Yeah. You're now taking another language. You're taking a language of chemistry. As this is the beginning of the language of chemistry. This is the alphabet. Okay? And we're learning how to use these, and our next part's going to be forming words with the alphabet. So. Anyway, moving on. Well, there's your quiz for Wednesday.
So how many terms is it? 11, 12, 13.
What are you saying?
Terms.
Oh my gosh.
I'm just gonna leave.
I'd say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 of just the representative elements, and then all the different possibilities for the transition metals. So we're talking
Like, so all the
70,
transition-
we're talking 70 or 80 possible.
Okay, well, those ones are all 1+ except these.
Those ones are all 1+.
Yeah.
Those ones what?
Like the group, like you know how it goes like 1, 2, big space of transition metals? Like those charges are all like 1+.
The transition metals?
Yes.
Oh, absolutely not. There's only about 3 of them that are 1+.
But that was the thing you just showed us with the Roman
Roman
numerals.
numeral. Right. The Roman numeral tells you the charge. Okay.
Got it.
We'll find out. Okay, I'm going to stop this now. I got all the information out there.
Wait, were you